This learning objective covers the 8 primary operators in the relational database management system. These 8 primary operators are restrict, project, product, divide, union, intersection, difference, and join. And this would be a good point to also talk about the 3 logical operations that can be combined with these primary operators, especially in the restrict case. And these include and, or, and not. So first of all, let's look at these logical operations. So they can be described by truth table or a Venn diagram. In case of truth table, if A and B is to be determined from A value combined with B value, then if both are true, then A and B will be true. And if either one of them is false, then the output will be false. Similarly, in case of A or B, if any one of them is true, then the output will be true. And the only case it is false is when both of them are false. In case of not, if A is true, then not A would be false. And if A is false, then not A would be true. This can be represented with Venn diagram, where if we are talking about A and B, then it's the common area between the two sets. And if we are talking about A or B, it's all of the area of the two sets. So A and B is like intersection, A or B is like union, and A to not A is like A complement. You're familiar from the set theory. Here's an example. Let's say if we are trying to differentiate between and, or, and not operation, then a peanut butter and jelly sandwich would be only the sandwiches that will have both peanut butter and jelly on them. Whereas peanut butter or jelly sandwich could include the sandwiches that have only jelly on them, only peanut butter, or both. And if we are looking at not jelly sandwiches, these will be the sandwiches that have only peanut butter on them, or nothing if we are looking at the outside part as well. Now, talking about the relational database management system operators, the restrict operator selects a subset of rows. So for example, if this was a table that we were dealing with, and we want to restrict this table using the condition that size is big or huge, then we will select all of those rows that have size equal to big or size equal to huge, which will end up selecting these 4 subset rows from the main table. Okay. Similarly, when we are talking about project, then project is a subset of columns. So suppose we project our table using the condition that select ID, color, and size, then our output will have only the ID column, the color column, and the size column, and this would be the project of this table. The product is similar to the concept of multiplication, and it combines the 2 tables and creates a bigger table, but the process of combination restricts the unique values of one table with the unique values of the second table. So when we multiply these 2 tables, we have 2 unique values in this table, 1n, 2s, and 2 unique values here, yes and no. So the output will have 2 times 2, 4 rows, where every unique combination is registered only once. And the other part of the other operator, kind of the opposite of product, is the divide operator. And it basically requires a third table which serves as the basis of the division. So in this case, we find the rows of the first table that match all the rows of the second table in the basis table. So divide A divided by B based upon this table. So if this was, let's say, states and these were ethnicities, then our division process is trying to find all the states that have these ethnicities in this table. So if we divide this table of type with size based on this table, we look at M in this table and see, are there M entries with both 1 and 2? So M has 1, M2 exists. That means this is one of the outputs. N and 1, 2. N2 exists, but N1 does not exist, which means we cannot use this as an answer. Similarly, R1 exists, but no R2, only R3. So R cannot be the outcome of the division. So in the division process, we divide one table with the other table based upon some basis table. Union is very much like the union in set theory, and we basically combine the two tables to form a bigger table where all the rows of one table are combined or concatenated with the rows of the other table. One of the things that you have to make sure that both the tables have exactly same attributes, otherwise they cannot be united or unioned. And similarly, intersection finds the rows that are common in both the tables. So the rows that appear in both tables will become part of the output. The operator difference is also like union, and in this case, A minus B means all of the rows that are contained in A but not in B. So in this case, 1 is appearing in both cases, so that cannot be output. But 2 appears in A but not in B, so 2 will be the output. So just like the difference operator in the set theory. And lastly, we have the join operator, and this is again creating a bigger table using the individual input tables. So in this case, we have a foreign key and a corresponding primary key in the first table, and then we join them to form a bigger table where if we are looking at the ID and type, so where we have A, we have 3 more columns, color, size, and age, and the corresponding values for the A type from the second table will be added or placed in the bigger table. And this way we end up creating a bigger table. This is the same idea when we were creating a in the normalization process. We split our big table into small tables with primary and foreign keys. This primary key should be over here. This is a typo. So we combine primary and foreign keys, but in case of normalization process, we split the table to form individual tables with some schema behind it. In join process, we do the opposite. We combine the tables that have some primary and foreign key to create a bigger table.